Hi everybody, welcome to our channel Mass Insights. In this video, we are going to discuss very important mathematical conclusion, that is basic proportionality theorem or Thales theorem. The applications of this theorem are using by students in the different academic classes and for others who are preparing for competitive exams. It is very useful to solve the problems in the exams. Shall we discuss in detail? The statement of basic proportionality or Thales theorem says that in any triangle, if you draw a line segment parallel to one side, then that line segment will divide the other two sides in the same ratio. This is very important. See, I am taking a triangle ABC. I have drawn a line segment or a line DE which is intersecting the other two sides AB and AC at two different points D and E. Will divide these two sides in the same ratio. That means given is in triangle ABC, they have given you this DE is parallel to one side BC. You may draw this line segment parallel to any other two sides also, that is your choice. And required to prove, RTP means required to prove. You have to prove that this line segment will divide the other two sides in the same ratio. That means AD by DB, AD by DP, this is the ratio which will become equal to AE by EC. So for that we have to do some constructions. You have to join BE. See, I am joining BE and also CD. After joining these two, I will draw DM perpendicular to AC. DM. So perpendicular to AC. I am drawing a perpendicular onto DC. Therefore, this is 90 degrees. And also another perpendicular EN, which is perpendicular to AB. This is the side AB. From E, I am drawing another perpendicular here. To prove that these ratios are equal, I will explain the procedure first, then we will proceed accordingly to prove the ratio is equal. See, I will take the ratio of areas of two triangles, that is ADE and EDB. Again, I will take the ratio of areas of ADE and EDC. So, I will take on either two sides of the triangle, then we will get two equations. After that, I will use one already proved geometrical conclusion that the areas of two triangles which are on the same base and are between same parallel lines, then those areas are equal. By using these three equations, I will get these ratios are equal. So first one is in triangle. So in triangle ADE, very simple, don't confuse. See, this is the triangle ADE. For this, I am taking area. Area of any triangle with the base and height is half into base into height. That means half into area is equals to half into base. See, in this case, I am taking AD as my base. You may take any base, but for that you have to have the height which is perpendicular to that base. But I have my perpendicular NE to this base AD. Therefore, I am taking my base as AD and height as NE. Okay, and in triangle, what I said, EDB. EDB area is equals to same formula, half into base into height, but for this EDB you have the height outside the base. For some triangles you may have a perpendicular to the base which is outside the triangle, so NE will become base to the triangle also. Therefore half into dB into again NE. Very simple. I am taking same height for these triangles. So now ratio is equals to, see, I am writing AR means area of triangle ADE by area of triangle EDB, that is equals to half into, see, this is half into AD into NE by again half into, see, this is the area dB into NE. If you cancel half and NE, then you will get AD by, this is AD by dB, let it be equation number 1. Similarly, I will proceed taking the ratio of areas of the triangles ADE and EDC. Therefore, ratio of areas of, see, this is areas of triangle, that is ADE, comma triangle, see, this is another triangle EDC, that is equals to area of triangle ADE, okay, by area of triangle EDC. Similarly, you have the base DM for the triangle ADE. I said previously that you may have different heights for the triangle. Whatever the base, whatever the height you are taking, you will get the same area for the triangle. Therefore, I am changing base and height. See, for this ADE, I am taking AE as my base, AE into, that is base, and height is DM. See, this is DM by half into again I am taking this EDC. For the triangle I am taking DM as my height. So for this triangle also, since it is an obtuse angle triangle, the height will be outside the triangle. Therefore half into base is EC into height is DM. If you cancel this DM and half into half, that is equals to, you will get area of triangle ADE by, this is ADE by area of triangle EDC, that is equals to AE by EC. Let this as number 2. Here we have to use the known geometrical statement, that is areas of two triangles which are on the same base and are between same parallel lines, then those areas are equal. If you observe the triangle BDE and CDE, they have the same base DE and they are between same parallel lines, therefore their areas are equal. We know that we have to write, we know that area of triangle this BDE is equals to area of triangle CDE, that is equals to, if you observe, you have to write why, because it is, why, because DE is parallel to BC and DE is common base. You have to write common base since they are between same parallel lines having same base. If you observe, if these two areas are equal, then see, you are having this ADE is same in equation number 1 and 2, but what is the difference between these two is EDB and EDC. But you know that area of EDB is equals to CDE. CDE or EDC both are same. Let it be equation number 3. So from 1 comma equation 2 and 3, we conclude that if these two are equal, the difference between these two is only the denominator. And we are proving that the denominator is also equal, therefore these two will become equal automatically. When LHS are equal, RHS will also become equal. Therefore I am writing that from 1, 2 and 3 you will have equality of these two ratios. That means AD by DB is equals to AE by EC. AE by EC. So this is the DE which is dividing the other two sides. This is one side and that is another side in the same ratio. That means AD by DB is equals to AE by EC. This is the conclusion. Basing on this theorem, we will prove some problems in the next video. And I hope that you may have liked this video. If you like my video, kindly don't forget to subscribe and don't forget to press bell icon, and we will meet in the next problematic video. Until then, have a nice day. Thank you very much.